Okay, I've already made a few videos where we looked at rational functions and then we found the graph for them. For this video, this should be very brief. We're actually going to go backwards, because if you can go backwards on a problem, it kind of shows that you really understand it. So here, I gave you the graph of a rational function. See if you can actually come up with the rational function itself using your knowledge of rational functions. It's actually not all that hard. If it's going to be a rational function, I'll just draw a line for my rational function. And now use what we know. Let's see if we remember the rules. Anywhere there's a hole in your graph, that means you had a factor that canceled out of the numerator and the denominator. In this case, there's a hole at x equals -4. So I'll just put an x plus 4 in the numerator and the denominator of my graph. Because then when that canceled out, would give me the hole at -4 I want. Now if we remember, all of the zeros of the graph are zeros in the numerator. So since I have a 0 at -1, I'll put an x plus 1. I have a 0 at +1, I'll put an x minus 1. I have a 0 at 3, so I'll put an x minus 3. Now, anywhere I have a vertical asymptote, that's where the function is undefined, that's a 0 in the denominator. So since I have a vertical asymptote at 0, I'll stick an x here. If you want to put it in front, you can. And I have an asymptote at 5, so I'll put an x minus 5 here. Now the last thing we care about is the degrees of all those roots I put in there. And in this case, if we remember our rules, for the zeros on top, we don't have to worry about the hole, that's going to cancel out. For the zeros on top, the zeros of the function, we just look at the behavior around the 0. Here I cut through the axis, so that's odd degree, just leave it as 1. Here I cut through the axis, that's odd degree, so it's 1. Here I cut through the axis, that's odd degree, leave it as 1. For the zeros in the denominator, these two right here, the vertical asymptotes, we just look at the behavior around the asymptote, whether the sign switches or stays the same. Around this asymptote, it's positive infinity on both sides, the sign did not switch, which means it has to be even degree. So I'll just stick a 2 right there. At 5, the sign did not switch around the asymptote, it's positive infinity on both sides, which means it has to be even degree, so I'll put a 2 right there. Now I've actually accounted for all the information on the graph, except for the horizontal asymptote. It's clearly at 0, so now check the rational function you created and see if it gives you a horizontal asymptote at 0. If it does, you're good. If it doesn't, it means you messed up somewhere. If we check our degrees, 1 plus 1 plus 1 plus 1 is 4 on top. 1 plus 2 plus 2 is 5 on bottom. If we remember our rules, if the degree in the numerator is less than the degree in the denominator, we should get a horizontal asymptote at 0, which is exactly what we get. Horizontal at 0. So, this function works for this graph right here. What I would suggest you do, maybe just for fun, to see if you kind of are grasping this, randomly draw rational functions, and then see if you can come up with the actual algebraic rational function to match up with the graph that you create. As long as you follow the rules correctly, it should work.